Welcome to our video summary of Introduction to Transformers by Andrej Karpathy at Stanford University. The link to the full-hour lecture is listed in the description below. If you find this content a real time saver to explore new ideas, please hit the like button and subscribe for more. When you hear the word Transformers, you probably think of giant robots that turn into cars. But the Transformers that have quietly taken over the world in the last few years are something else entirely. These are the AI models behind ChatGPT, Stable Diffusion, and AlphaFold. They write code, create amazing art from a simple sentence, and even solve huge scientific problems like protein folding. They are, without a doubt, revolutionizing our world. But where did this all come from? It wasn't a slow, gradual change. It was an explosion. This is the story of one idea and one paper that changed everything. To really get it, we need to go back to the world of AI before 2017. AI researcher Andrej Karpathy calls this era the Dark Ages. Different fields of AI were like separate worlds. If you worked in computer vision, you used a totally different language than someone in natural language processing. Progress in one area just didn't translate to another. In the world of language, the main models were called recurrent neural networks, or RNNs, and they had a massive weakness. They were terrible at understanding long-range context. Imagine you told a model, "I grew up in France." Then a bunch of sentences later, "So I speak fluent." For a human, the answer French is obvious. But for an old RNN, the word France was too far away. It would get lost. This was the wall that all of AI had hit. The first big breakthrough was a mechanism called attention. The idea came from a researcher named Dmitry, who was frustrated with machine translation. He realized that when he learned English, his eyes would shift back and forth between his native language and the English text. So he built a mechanism that let the AI model soft search and look back at the most relevant parts of the original text as it generated each new word. And it worked on the very first try. The legendary AI pioneer Yoshua Bengio suggested a catchier name for it: attention. This was a great addition to the old models. In 2017, a team of researchers asked a radical question. What if attention wasn't just an addition? What if attention is all you need? In 2017, they published a paper with that exact title, Attention is All You Need. The idea was shockingly simple. Get rid of everything else. Ditch the RNNs and build an entire architecture using only the attention mechanism. The paper combined several powerful ideas into one package, creating an architecture so good that it's still the foundation for the massive models we use today, like GPT. So how do transformers actually work? Imagine each word in a sentence is a person in a room. First, everyone communicates. Each person broadcasts a question, like "here's what I'm looking for," and holds up a sign, like "here's what I'm about." Everyone looks at everyone else's question and sign, decides how much attention to pay, and gathers information. This happens all at once, giving every word rich context. After all that communication, each person takes a moment to think and process all the new information they just gathered. That's it. A transformer is just a series of these communicate, then compute blocks stacked together. Once the power of the transformer was proven, it triggered a Cambrian explosion across AI. Researchers realized they could copy-paste this architecture into totally different fields. For computer vision, you just chop an image into little squares and feed them into a transformer. For speech, you do the same thing with a visual representation of sound. Even AlphaFold, which solved the 50-year-old challenge of protein folding, has a transformer at its core. It works because transformers are incredibly flexible. You can just throw all kinds of data into the mix and let the attention mechanism figure out how it all connects. But there's one more secret to their power. The real magic happens when you give them a prompt. The GPT-3 paper showed that if you give a model a few examples of a task in the prompt itself, its accuracy on a new question skyrockets without any retraining. The model learns the task on the fly. This led Andrej Karpathy to his ultimate analogy. A large transformer is like a general-purpose computer. The prompt you write is the program written in natural language. The transformer then runs that program. So when you're writing a prompt, you're not just asking a question. You're writing code for a new kind of computer. From the fragmented dark ages of AI, a single human-inspired idea gave birth to a revolutionary paper. That paper introduced an architecture so powerful, it unified the entire field, and at scale, became a new kind of machine that runs on natural language. The journey is far from over. We're only just beginning to understand what we can build with it. Let us know your thoughts or suggestions for future content in the comments. Thanks for watching. We'll see you in the next one.